Hey guys, hope y'all had fun with the sub today. He said y'all were good, so it makes me happy. So tonight we are working on 2.4. Okay, I've forgotten the numbers. 2.4 special right triangles. Go ahead and label your notes. That would be perfect. So today's probably the most important of all the days that we're working on special right on triangles, because we will be using the rules that you see today like every day for the rest of the semester. So this is something you cannot hide from. You just have to learn it. Okay? So we're going to start off with the two special right triangles. They are 45, oops, I got ahead of myself, 45, 45, 90 triangles. And for all my students that had me for pre-AP geometry, y'all know this. 30, 60, 90 triangles. Okay? I'm going to write the rules down first, and then I'm going to give you some examples. We're going to work through them. So, the rules for 45, 45, 90s triangles are, you'll see it both ways. You'll see people write side. This is how I taught it in pre-AP geometry. Side square root of 2. And then I want to draw a picture too. How about that? So our triangle, it has to be right, obviously. So that tells me it's a 45, 45, 90. So you'll see people write side square root of 2. Or you'll also see, I'm going to start using this more because this is more pre-cal of me. It's writing 1, 1, and then write this as the square root of 2. Okay, so this is more pre-cal, writing 1, 1, square root of 2. The side is just saying that it's like a variable. So whatever the problem tells you that the S is, that's what you'll use. Okay, you'll see more once I give an example. Okay, now for the 30, 60, 90, it's S square root of 3 and 2 times your S value. Okay, let me draw a picture. So my 30 degrees is here. So opposite my 30 degrees is my S value. Opposite my 60 degrees is my S squared to 3. Opposite my 90 degrees, or it's my hypotenuse, is 2S. Again, if I'm going too fast, press pause and make sure you write this down. Okay, so this is my 1, this is my square root of 3 side, and this is my 2 side. Okay, so the blue is the pre-cal notion. Okay? So, let's do some examples. Okay? If I gave you a triangle, and I told you it was a 45, 45, 90, let's name this Y, this Z, and this X. Okay? So if I told you YZ was 5, would we be able to find the other two sides? Yes, you would, because 5 is my side length, therefore XY would be 5, and my hypotenuse would be my S times the square root of 2, so it'd be 5 square roots of 2. Okay? It's pretty simple when you're just looking at it like that. Okay? Now, where it gets a little bit trickier is, we're going to use the same picture. So Z, Y, and X. Okay, if I told you that xz had 2 square roots of 5. Can we find yz? Yes, we can. Okay, what we have to do is we know that 2 square roots of 5 is equal to s square roots of 2. We have to figure out what s is because s is the length of yz. Okay, so we are going to divide by the square root of 2 on both sides. So we have 2 square roots of 5 over the square root of 2. Okay. You can't have 2 radicals. I know on Monday I told y'all you can't, it's okay if you keep a radical on the bottom. It's okay as long as that there's not 2 radicals here. So the way you get rid of it is you move the radical to the top and you just change that to 2. So watch what happens. So I've got 2. Okay, I want to put these underneath the same square root, so it's 10 over 2. Okay, you can cancel that out. So my s value is the square root of 10. Okay. Let's do another one like that. Okay. If I have, again, we're going to use the same x, y, z problem. It's a 45, 45, 90. Okay. Yx, there is going to be the square root of 3 over 7. And I want to know what both the missing sides are. That's a question mark and a question mark there. Well, off the bat, you should know that yz, let's use green. We know that yz is automatically square root of 3 over 7, okay, because it's 45, 45, so it tells you that these two sides are the same. And we know that xz is we're going to take our side length, which is the square root of 3 over 7 times the square root of 2. I promise you guys, by the time you're done with this class, you're not going to be afraid of using square roots or fractions. Okay? Just put it over 1, put the square root of 2 over 1. You multiply straight across. Okay? Because these are both square roots, you can put them underneath the same square root and you multiply. So that's xz. It's that simple. Okay? All right. Let's move on to some 30, 60, 90 triangles. Okay? 30, 60, 90 triangles. So let me redraw my triangle. Okay, so this is my 1, this is square root of 3, and this is 2 times 1, or just 2. All right, first problem we're going to work through. Let's make this triangle S, R, and T. So this is my 30 degrees. Okay? Okay, if SR had a length of 7, could we figure out what TS was and RT was? Yes, we can. All you do is you're going to take 7 and you're going to multiply it by the square root of 3. So it is just 7 square roots of 3. Okay? And for RT, we just multiply it by 2. So RT is 14. Okay? I'm sure you're thinking, oh, that's not bad at all. I got this. It can get a little bit trickier. Okay? Just a little bit. Let me show you ways that it can. Okay. So let's redraw this triangle. So S is the right, T is my 30 degrees, R is my 60. So if ST had a length of 2 square roots of 5, okay, can we find the rest of the sides of the triangle? Okay, the way you start off these problems, you need to find S. So you set whatever side length they give you equal to whatever ratio. Okay, so for this ratio, it's S square roots of 3. So that is our problem. We have S square roots of 3 equal to 2 square roots of 5. We have to solve for S. You're going to divide by the square root of 3. So you get S is equal to 2 square roots of 5 over the square root of 3. Okay, just like I mentioned earlier, you can't have a square root on the bottom when there's a square root on the top as well. So this can just change to 3 as long as you multiply by the square root of 3 on top. Those are equal. So we've got 2 square roots, and do not tell me that it's a square root of 8. You multiply. There's no addition sign here. Multiply. So 2 square roots of 15 all over 3. Okay? No, you cannot divide underneath the square root because there's not a square root here. And 2 and 3 don't simplify. So that is our answer for RS. That's 15 over 3. Okay? Now to find RT, we're just going to take 2 times our side length, which is 2 square roots of 15 over 3. Okay? Again, you're going to be extremely comfortable with dealing with fractions once you're done with this class. Okay, whenever you see a whole number, just put it under 1 and you multiply straight across. Okay, you multiply like terms too. Okay, don't tell me this is 4 square roots of 30. This is 4 square roots of 15. Okay? You'll hear me say this a lot, but if you're confused on what to do, make the square root of 15 an x value. So if you had 2 times 2 x over 3, you'd still get 4x over 3, which is what we have here. Okay? If that confused you more, then disregard. I'm sorry. It is not my goal. Okay? So that is RT right there. Okay? And that pretty much sums up our notes for today. I'm going to have a worksheet for y'all tomorrow in class. And I'm also going to be grading all the homework from this week for triangles. So make sure you have it all complete. And if you have any questions for me, because we're having a quiz on Friday. Sounds good? Thanks, y'all.